Hi, my name is Kevin Jones, and this is the Introduction to .NET Core class from Wintellect Now. .NET Core is the new cross-platform version of .NET from Microsoft. So this version of .NET runs on Windows, as you'd expect, but there's also a version that runs on Linux and a version that runs on Mac OS X. In this class, we'll take a look at how we install and initially use .NET Core. .NET Core comes with a set of command line tools and is also supported by Visual Studio. So we'll see both of these uses. We'll see how to use the command line tools, both on Windows and on Linux, and we'll see the Visual Studio support in action by building a project inside Visual Studio. So in this class, we'll take a look at installation. So how do we install .NET Core? Again, we'll take a look at how we install this on Windows. We'll take a look at how we install this on Linux and how we use the tools from Linux. We'll take a look at those command line tools, what they provide for us, how we use them, how we build projects, and how we run projects. We'll take a look at unit testing. So how do I bring unit testing into my .NET Core project? How do I include the appropriate packages to use unit testing? We'll take a look at how we use this inside Visual Studio, how to install it inside Visual Studio, and how Visual Studio can use .NET Core projects. And finally, we'll take a look at mixing .NET Core with other .NET projects. So on the basis that you're not starting from scratch, that you don't just build .NET Core projects, but that you have existing .NET libraries out there, how do we use these together? Okay, so let's dive in. The first thing we're going to do is take a look at installation. How do we install .NET Core? So when you install .NET Core, you get a new set of command line tools for whichever platform you install .NET Core onto. So tooling for Windows, tooling for Macs, and tooling for Linux. The installation for each platform is slightly different. So on Windows, we install this as part of Visual Studio 2015. To do this, we need to install Visual Studio 2015 Update 3 and then run this .NET Core 1.0.0 tooling preview. It's the tooling preview that gives us the .NET Core command line tooling that we need. This obviously is at the time of recording. Undoubtedly going forward, we'll get release versions of these tools that will come as part of Visual Studio. For Linux, the installation is slightly different for different versions of Linux. And at the moment, there are only certain supported versions of Linux. And we'll take a look at Ubuntu 16.04 here and install .NET Core on that. To do this, as we'll see, we need to set up the correct repository. We then run apt-get to get the packages. And this gives us access then to the .NET Core tools. Okay, so let's go and see how we do this now for both platforms. So to get instructions on how to install on the various platforms, you can go to microsoft.com/net/core, and then on here, you'll see you can click on Windows, Linux, Mac, and there's also a Docker install, and whichever of these buttons you click on, you get information on how to install .NET Core on that platform. I'm not going to run through installation on Windows here. It's not something you'll want to sit down and watch me do. It's a matter of running the installer and watching it install. There are two parts to this. You have to make sure you have Visual Studio Update 3 installed. You can install that on any of the MSDN releases of Visual Studio or on Community Edition. The second part, though, is to install the tooling preview. One thing to be aware of when you install the tooling preview, and I've had this happen to me each time I've installed it, is it will occasionally fail. It will come up with this message saying, setup failed, please repair Visual Studio. If you see that, the way around it is to run the installation with this skip_VSU_check equals 1. That will skip the update check and then go ahead and install the tools that you need. Once you've installed the tooling on Windows, you can then go to a command prompt and run .NET. And what we see here is the output from running the .NET tooling on Windows. If I run .NET --help, then we'll get the help for this, and we'll take a look at this in more detail through the rest of this class. So what I'm going to show in a little more detail is how to install .NET Core on Linux. And for this, we're going to use Ubuntu, and this is version 16.04, which is one of the supported versions of Linux. There are other supported versions, so Ubuntu 14.04, there's a Red Hat Enterprise version, some Debian versions, Fedora. So there are quite a lot of supported versions of Linux that .NET Core will run on. So to install this on Linux, we'll do this through the terminal application. So in here, we're going to run some commands, and those commands are going to change apt, the package manager, to point at the correct repository. We need to add a key so that apt trusts that repository. And then once we have that, we can then get apt to go and download .NET Core for us. So 3 steps that we have to go through. So the first command is this. And what this command does essentially is that it adds a new package repository to the list of packages that Ubuntu knows how to use. And we do that by running the deb command. We're using sudo here, so we're running this as the super user. And once I enter my password, then it will add the name of that repository to the locally held list of repositories. So when I use apt now, it knows it can use this repository to get some packages from. Once we have that, we have to tell apt that it can trust this repository. So we do that by adding a key. So it's going to get the key and now trust the repository. And then we need to tell apt to update the list of packages that it knows about. So in this case, we're going to add to its internal list of packages the set of .NET packages that come from Microsoft. We do a sudo apt-get, which is the apt tool, and then tell it to update itself. So this could take a while. It goes to the list of repositories it knows about and downloads the package details from those repositories, including now the .NET repository. Once we have this, we can now install .NET. Now, at the moment, we're installing still a preview version of .NET. In the future, this will just be a 1.0.0 release, but currently we're still on the preview here. So we say to apt, by using the apt-get tool, go and install this package for me. So it asks me, do I want to continue the operation? Do I want to install these packages? I'll say yes. So it downloads these packages, creates the appropriate links for me inside Linux, and this should now be ready to use. So if I run .NET here, then we get information about the .NET build. And again, if I do .NET ---- help, we get the same help information that we saw on Windows. So it's relatively straightforward to install these packages on Linux. Even if you're a complete newbie to Linux, it's not hard to install these, not hard to try these out and to play with .NET on Linux. So now that we've seen how to install .NET Core, we'll take a look at the tooling. And here we'll take a look at the command line tools, and we'll do this on Windows. So .NET Core comes with a set of command line tools, and these tools are used to both generate, build, and run applications. The name of the tool that we use primarily is .NET. We can use this to create a project for us, and then we can use this to compile and run that project code. This generates a project.json file. This is likely to change. So since the latest release candidates, Microsoft have announced that they're moving back to the CS_proj type projects rather than JSON type projects, so using XML to hold the project structure. This project file contains project references and details of the application or library that we are building. So for a demo, we're going to use the tooling to create a simple application and run the application just to show how it works. Once we have that in place, we'll then build a slightly more complex application where we'll build both a library, a DLL, and we'll build an application to actually use that library. So let's see how we do that now. So we saw a few minutes ago that to run the .NET tools from the command line, we use the .NET command. So this comes up with some version information and some simple help information and tells us that we can run .NET help to get a bit more details. So if we do that, we run .NET ---- help. Then this tells us that we can pass various arguments to this tool. So at the bottom here, we see that we can say .NET new, and that will initialize a basic .NET project for us. We see that we can also do some other things like building the project, running the project, and also doing things like restoring dependencies. And we'll see each of these commands as we go through this over the next few minutes. So I'm in a demos directory here, and I'm going to create a new directory called character counter and change that directory And it's in this directory that we'll build the project. So we'll start with a simple project, and then we'll show how we can build a multi-part project. So a project that uses both a library and an application. So to build the project using .NET Core, we simply do .NET new. And that creates the project for me. And if I look in this directory, we see that we have two things. We have a program.cs file, and we have a project.json file. So before we go any further, let's take a look at that project.json file. So I've opened the project.json file inside Visual Studio Code, and we can see here the sections it contains. So it's telling me that this is version 1 of the application. It's telling me that I have no dependencies, and it's also telling me that I'm using the .NET Core framework here. If I open the program.cs file, as you'd expect, it's a very simple Hello World application. So it creates this code for me. It creates the namespace. It creates the program. It adds public static void main, and then it just writes out Hello World. Once we have that in place, we can run the application. But before we do that, we have to run .NET Restore to restore any dependencies that this application relies on. So before we run .NET Restore, let's remind ourselves what's in this directory. So we have a program.cs file and a project.json file. So if I run .NET Restore, and now look in the directory, it creates another file here called project.lock.json. And if I open this file in Visual Studio Code, we can see this contains a whole set of information about the dependencies this application uses. So when you run restore, the tooling goes away, looks at the dependencies of our project, and then tracks all their dependencies and builds this dependency tree. It also downloads any extra packages that we need to use. This is sort of like the packages.config file that we get in current .NET projects that tells us what packages this project depends on. So if this file is the equivalent of the project level packages file, where are the packages themselves? Well, .NET Core stores these packages in a central location. So it's your home folder, which will be users/username, so Kevin Jones in my case, /NuGet/packages. And if I look in here, we can see that there's a whole set of directories that contain various .NET libraries, DLLs, packages, license information. Basically, we've downloaded the packages that were in NuGet to a local cache for us to use them. I can safely delete this packages folder. And then if I run .NET Restore again, it's now going to go away and recreate that folder for me. And if I look back inside my .NuGet directory, sure enough, the packages are now back. So let's try one other thing. If I delete the packages folder, so that's now gone, I'm going back to my application, and I'm going to remove the character counter application. The application has now been deleted. If I then recreate the application, so from here now I'm going to run .NET new to create a new application. So now this is as if I'm running .NET for the first time. There's no packages folder, there's no application, and this is probably what you will see the first time you run .NET from a command line after you've installed it. At this point it says, you're going to need these packages. So the first thing it does is goes away and recreates this packages folder for me. So from now on, every time I create a new .NET application, that packages folder exists and it's pre-populated with the dependencies that we'll typically need as part of our application, i.e. all the .NET dependencies. From here, I still need to run .NET Restore. And .NET Restore still creates that lock file for me, so project.lock.json. So .NET Restore basically looks at our project.json file, and then from that, works out the tree of dependencies that this project needs. If there's anything in that tree that isn't in the packages folder, it will go away and download those packages as well, and we'll see that a little later. The lock file, you don't need to check into source controls. You should check in your project.json file, you check in the .cs files, but you don't need to check in the log file. That's easily recreated just by running .NET Restore. So now that we have this application created, we can do .NET build. And that's going to build the application for me. And if I look at the generated code for this, so we have a bin folder, debug folder, .NET Core app folder. Inside here, we don't have an exe file. We have a DLL. So when I run the application, this is run via .NET Core, and .NET Core loads the DLL for me, looks for the entry point, and executes that entry point. So very similar in the way Java works. So in Java, we end up with .class files that we load, and we look for an entry point called main. So a similar thing here. We have a .dll, we load that file, we look for an entry point, and if it's there, then that application will run. So I go back to my command line, I can do .NET run, and that runs the application, and sure enough, it prints out hello world. Now, I don't need to do these separate steps. I don't need to build and then run. If I run and the application needs to be compiled, then it will be recompiled for me. And we can see that if I delete the bin and obj directories, and then go back to my command line and do .NET run, compiles the code, runs it, and sure enough, we get hello world. So this is obviously a very simple application. It's just hello world. When we create more complex applications, we have to manage things like the layout of our code. So where do things go on disk? And there's a structure that's recommended that we use when we build .NET Core applications. And that's to have two folders, a source folder and a test folder. Put our source files in one location in the source folder, and then put any test files that we have in the test folder. And we'll see the tests a little later on in this class. So what we're now going to do is we're going to make a slightly more complex application that has both a library and an executable, so a lib and an exe. So a lib and an application, if you like. And when we do that, we want to put our code into the correct structure. So the first thing I'm going to do is to create a source directory and then change into that. And then in here, we'll create two projects, one that will be the exe and one that will be the lib, and one will depend on the other. So from here, I'm going to create two projects. I'm going to create a project called character counter lib, and that will be our library that will contain the helper code inside it. And I'm going to create another project called character counter app. In the lib folder, I'm going to again do a .NET new to create the project JSON file and the initial code. We won't need the program CS file in here, so we'll delete that eventually. And then in the character counter app folder, I'll do the same thing. So if I look in the source folder and look at character counter lib, sure enough, we have a project JSON file and a program CS. I'm going to delete the CS file here. We don't need that. And if I go back into character counter app, we have the same thing. We have a project JSON file and a program CS file. So this course isn't about how to write .NET code, so I'm not going to show you step by step how to write this code. What I'm going to do is to bring the code in and then show how to amend the project JSON files, and then show how to create a top-level global.json file that allows us to set up a multi-project application. So first things first, let's take a look at the project JSON files. So this is the one for the app, and at the moment this will be exactly the same as the one for the library, for the DLL. Notice in here it says emit entry point true. So that says that it needs to emit into its metadata the fact that this is an exe, that it has an entry point, which will be main in this case. If I open up the project JSON file for the lib, look inside here, this also says emit entry point true, but this is not going to be an exe, it's just going to be a DLL, so we can get rid of that here. Now, the other thing that we're going to have here is a dependency. Our application will depend on the library. So I need to add that dependency into the project JSON file. And to do that, we have to tell the project JSON file that we are adding a project dependency, not a DLL dependency, and that we depend on the project called character counter lib. So to do that, in my dependency section, I add an entry called character counter lib. This is the key for my dependency. And inside here, we specify the target for the dependency, and the target is going to be that it's a project dependency. So we're now saying that our application project depends on the lib project. So now that we have the project files for these projects, let's take a look at what this application actually does. So if I look at the library first of all, what this code is going to do is something quite straightforward. It's going to read a string that we pass to it and count the numbers of characters in that string. So the numbers of A's, number of B's, number of C's, and so on and so forth, and pass back that information to the caller. So we hold a dictionary, that's the character against the count for that character. We turn the string into a char array, and then for every letter that we have inside the phrase, we just increment a counter. We can pass back that dictionary so that a user of this application gets back a list of the characters and the number of characters inside this string. So a very, very straightforward little library. And the application code that we have for this will basically let me do two things. I can either pass it a file, and then I can pass that entire file off to the character counter library, or I can enter a phrase from the command line, and I can pass that phrase off to the character counter library. And at the end of this here, we can see that the code creates a new character counter, so that's the library code, calls its parseString method, and then just prints out the count for each letter that's in the data that we've parsed here. So this is a multi-project application. And to let .NET Core know that, we have to create a top-level JSON file called global.json. And that global.json file lists all the sub-projects that make up this one large project. So in my demos character counter folder, I'm going to create a new file called global.json. I'll open that inside Visual Studio Code. And inside here, we add a JSON object that contains a project's key, and that key will reference an array, and that array just contains the location of the project folders that we're going to use. So the primary use of this is when we have multiple folders. So when we have a source folder and a test folder. So at the moment, we only have a source folder, so we'll leave that as it is for now. When we change the project to add tests to it a little later, we'll come back to this and we'll add the tests folder to it. So we've now created everything we need for this project. Back at the command line here, I'm in the top level directory. If I go into my source directory and then into character counter app, say, from here I can run .NET restore, and that will look at my project JSON file, look at the dependencies, and set up my project.lock.json file. I also need to do this for my lib folder. However, if I go back to the root folder for the project, the one that contains global.json and the source folders, and do .NET restore from here, this will look in the source folder. In there, it will parse down through all the child folders, find a project.json file in the lib folder, find a project.json file in the app folder, and then generate the appropriate lock files in those folders. So the major benefit of having the global JSON file is the fact that I can run .NET Restore at the top level. I don't need to run this for each sub-project that I have. I can just do the restore and create the lock file in one single place. Now that I have the project structure set up, and I have the restore run, and we have the dependencies all set, and the app knows that it depends on the lib, I can go into the app directory and run the application. So I can do .NET run. And the first thing this will do is compile the application, and then it will run the app. And the app says enter a phrase, so I can say something like this is a test, and it will output the counts for me. So there's 1A, 1E, and so on and so forth. If I look in the appropriate directories here, so in character counter lib, look in the bin folder, then we have the lib and the PDB. If I go back to character counter app and look in its bin folder, then we have the apps DLL and the PDB, but we also copy across here the lib DLL and PDB. So that dependency has been resolved, and we copy across the appropriate libraries that we need to use. Notice that when I ran this, I just did .NET run. I didn't enter a command line parameter. So it just then asks for a phrase from the console, we type something in, and it does the count. If I run this with a parameter, so say .NET run, and then pass it, say, program.cs, it will read program.cs as its input. And in this case, it doesn't need to recompile everything. Everything's already compiled. And again, it walks through program.cs and outputs these counts onto the screen. So in this case, we have 44 A's and 61 E's and so on and so forth. So we can pass command line parameters into the applications by passing the parameter to the run command itself. So what good is a project without tests? So now that we have the code in place, we'll add some tests. Obviously, if this is backwards, we should be doing the tests first. But the idea here is obviously to show you how to use .NET Core, not best practices when it comes to .NET development necessarily. So let's get on to testing. We are going to add unit testing to the project. And we do that by adding a unit test project as part of our main project. So we create a separate test folder, and inside that test folder we create another project, and inside there we'll create the code that runs the tests. And for this, we're going to use XUnit as the test library. So previously we created the character count application, and inside here we have the source folder and then the app and lib folders. Now what I want to do here is to go back and also create a test folder. It's inside that test folder that we'll create the test project, and inside there add the tests that we'll use to test the character count at lib in this case. So with the .NET command line tools, we can get help at the global level. So we've seen that I can run .NET --help. But we can also get help for each of the commands. So if I do .NET new --help, then it tells you the options that I can use in the .NET new command. And one of those options is -t. And -t lets me specify the type of project I want to build. And one of the types of projects we can build is a test project using XUnit as the test library. So from here, if I do .NET new -t and then say XUnit test, then that will have created me a test project. So if I look in the test folder that I created, we have two things. We have a project JSON file and a tests.cs. Rather than create a program.cs, it creates a test.cs that contains the outlines of the test project. If I open in the test folder that project.json file, we'll see that in here it holds information about how we're going to do the test. It has a dependency on .NET test XUnit. It has a test runner, which is the XUnit test runner. And if I open up the test file, we'll see that this is specifying that we have a class called tests, and XUnit uses facts. So we have a fact that's an attribute on the test one, and that's the first test we will run. Back at the command line, if I run .NET restore here on the test project, this goes away and downloads all the dependencies we need for testing. In particular, if I scroll back up through this list, we'll see that XUnit is now in that list. So now that the project's in place, let's go and write some tests. So I'm going to change the name of this from just tests to be character counter tests. I'm going to change the name of my class to the name of the test, and that's going to be get count for letter. And then change the name of the test to specify what this test should do. And that's going to be should return a count of 1 if there's a single letter to parse. And then in the code, create a new character counter called parseString, passing it a single letter, and assert that we get back a count of 1 for the letter A. Now that we have the code in place, we can do a .NET build. And the build fails. And the reason the build fails, of course, is that we haven't added the project reference to our project.json file. So let's go back and do that now. So if you remember, we do this in the dependencies. So in here, we're saying we want a dependency on character counter lib, And this dependency, the target type for this is a project. And if we now do a .NET restore, and then a .NET build, the code builds okay, and we can do a .NET test, and that will run the tests. Okay, just as an aside, I hate seeing tests run and succeed first time, as I'm never sure if the test is correct or not, or if my code is correct or not. I like to see tests fail. So to do that, let's change the assert here. So let's say I'm expecting the value 2 to come back, and this should fail. So if I save the code, go back, build it again, and then run the test again, sure enough, now the test fails. So that proves to me that we are actually running the correct test. I always like to see that. So there's one last thing to do here. We need to update our global JSON file. So you remember this file looked like this. It says we have some projects in the source folder, and now we need to add the test folder to this. If I do that and go back to my command prompt and go to the top level directory, this is where global.json lives. From here, I can now do a .NET restore. And that will run restore both on the source folder project and on the test folder projects. And that's how we add tests into a .NET Core project. So we've seen the command line tools. What about Visual Studio? So to use this current version of .NET Core inside Visual Studio, you at least need to use Update 3 of Visual Studio. And you can download that from Microsoft and go and install it. You also ideally need to install the command line tools as well, as we saw earlier. Update 3 can open the JSON project file, so it understands the file format that it's using. We can use it to build and run the code, and we can also use it to run unit tests as well. So everything that you've seen me do from the command line, we can do it just as easily from inside Visual Studio. So we'll take a look now at how we do that. We'll do that by opening up our project that we've been using and then build on that project inside Visual Studio. So the first thing I want to do here is to show you how to create a new project inside Visual Studio. So if I do File, New Project here, we can create a .NET Core project. I'm going to create a class library project. And this is just a temporary project, I'll create the project in my temp directory and say OK. So what this does is it creates the project for me. I have a solution. Inside the solution, notice we have a global JSON file, and I can look at that. And inside here, it's telling me project folders we're going to have, so source and test. And we have a project JSON file, and we have a class file. So class1.cs is just a standard .NET class, and then my project JSON file contains my project dependencies, just like before. And if I look in the temp Kevin folder, we can see we have the same structure. So we have a global JSON file here. It's created the .NET solution file for me, and then we have a source folder with the project JSON file inside here, and then my class file inside here as well. Notice we also have this xproj file here. So the xproj file is the .NET Core equivalent of a csproj file. At the moment, Visual Studio uses both. It uses the JSON file to contain the dependencies, and then the xproj file to contain the build information. Although it's likely that in the future we'll move back to using a csproj file format rather than the xproj file format. So once we've created this project, we can build it in the same way we'd build any other .NET project. And we could run it in the same way that we would run any other .NET project, except of course we built a DLL rather than a console application, so the code won't run directly at the moment. So what about the projects we built previously? The character counter lib and the app and the test project. Well, we can import those into .NET. I can go File, New, Project, and then create a Visual Studio solution. And I'm going to put this in my character counter folder. And we'll call it character counter. So once we have that in place, I'm going to add a couple of solution folders. One called Source and one called Test. And these are just here to mirror the folders that we have on the file system. So we can structure our Visual Studio solution in the same way that we structure the projects on the file system. Having done that, I can then add an existing project. So I'm going to go to character counter, source, character counter lib, and open up the project JSON file. And we add that in, and it just puts it in the source folder, opens up and creates a project JSON file for me to use. So it just reads this as if it was any other Visual Studio project. If I look on disk now and look at the lib folder, we'll see that Visual Studio has created an Xproj project file for me. So in the same way as if we did this by doing file new project, by importing it, it creates the Xproj file for me as well. The other thing we could do, if I go and delete that project from Visual Studio, go back to the directory and delete the Xproj files as well, and then in Visual Studio do add existing project and go to the app project instead and open up its project JSON file. Notice that Visual Studio is smart enough to look inside the app project, recognize the fact that we had a dependency between the app and the lib, and import both of those into my solution. And in fact, it would do the same thing if I opened up the test proj file as well. It would recognize that the test project depends on the lib project and read both of those into the solution as well. So let's go and add the test project now. So we do add existing project, go to the test directory, find the project file, and sure enough, it brings in the test project as well. So notice that when I've done this with the test project, I'm getting some little sort of green squigglies here. So there's something not quite right. It's obviously not something that's disastrous, otherwise they would probably come up in red. If I hover over this, it tells me that the version of XUnit has changed and probably updated. And you may have noticed this earlier when I was running this tooling from the command line. It kept warning me of a different version of XUnit that was available. So rather than running this RC2 192208 build, I now have a build 10015 I can use. So if I pin the solution folder open up the test project, and change this to build 10015, and then save the solution file, notice that it says restoring one package, so it does the package restore for me automatically, and everything now goes green. In fact, the underscore should have disappeared in the project JSON file as well. If I reopen that, then they've gone as well. So Visual Studio is trying to be helpful to us and trying to give us little warnings about things that we could fix inside the projects. So I can also manage packages using NuGet. So if I right-click and do Manage NuGet Packages and look at the XUnit, it says they're up to date. If I include pre-release here, we see that both for XUnit and the .NET Test XUnit, there are pre-release versions. So if I update each of these, I get the usual NuGet dialogues, and do the same for XUnit, then my code is now fully up to date. So notice that my project JSON file has changed. It's now showing me the 2.2 preview release of XUnit. So the project reference information is held in the project JSON file at the moment. Okay, so if I close that, I can now use this as a normal Visual Studio environment. So I can do a build, I can build the solution. And that's going to build the app, the lib, and the test projects for me if it needs to. I can also run the app. It's identified the character counter app is the application. So I can run this. It asks me to enter a phrase. So again, this is a test. And it gives me the output from the phrase. We can also pass a command line parameter to this, so the same as we did before, so program.cs. And if I save the project file, so this will be the Xproj file in this case, and then run the code, again we get similar output, so 44 A's and 61 E's, so the same as before. So this is very, very similar to a normal .NET Visual Studio experience when we're using .NET Core. So one other thing we can do is we can run tests. So if I go to Test Explorer and do run all, it's identified the tests that are part of the project. And we're doing run all. It runs the test for me and shows the test passes. And again, just to prove that we are running the correct test, if we change that value to 2 and save it and do run all again, then the test now fails. So it is running the correct tests. So one last thing I want to do here is to add another NuGet package just to show that we can add other libraries into our .NET libraries. So if I go to my test project and do manage NuGet packages again, I'm going to find a library called Fluent Assertions. And Fluent Assertions lets me write my test assertions to assert.true in a slightly different way, in using what's called a Fluent style. So if I install this into my project, notice it does a restoring packages. Look in the project JSON file, and it references the Fluent Assertions assembly. And then in my test code, rather than using assert.equal here, I can now use a style something like this. So I can say counter.getCount.letter.should, and this comes from Fluent Assertions.b1. So I'm now able to read my assertion code left to right. So we use this Fluent style to do this. And I'm using Fluent Assertions, which is a standard .NET package. I can use this in any of my .NET projects. And if I build the code, everything builds okay, go back to the Test Explorer and run all the tests again, then the test pass. So everything is green. So we can include packages inside our .NET Core projects and make use of those. So our last topic is mixing .NET Core with other .NET project types. So we can do this, and we do this from inside Visual Studio. So what we'll do is we'll create a new Visual Studio project, and to that we'll add a .NET Core project, and we'll show that how that still works inside Visual Studio with the standard .NET Core project and how the tests still run. And then we'll add a .NET console application and show that interacting with the .NET Core project. And we show the changes we might need to make to the project files to get that to work. So now that we have the project loaded into Visual Studio, what I now want to take a look at is how we can mix and match .NET Core projects and standard Visual Studio projects. And to do that, I'm going to start from scratch again. So we're going to create a Visual Studio solution. We're going to create a .NET Core library in that solution. We'll reuse the code that we had previously, but we'll create the new project JSON file. And then to that, we'll add a .NET console application, not a .NET Core console application, it's a .NET 4.6 console application. So to do this, we'll do File New, and we'll create a project, and it's going to be my Visual Studio Solution project. And we'll call this Character Counter, and we'll place it in the Character Counter Demos folder. Then in here, we'll do what we did before. So we'll add a new solution folder called Source. And then into here, we'll add a new project. And this time, we'll add a .NET Core class library project, and we'll give it the same name. So we'll call it Character Counter Lib, and we'll make sure it goes into the source folder here. And this is going to be a .NET Core class library project. So we say OK for that. It restores the packages and everything is good to go. So there's the project inside the source folder. If I go to Explorer here, we can see we have our character counter source, character counter lib, and then we have this class1 CS file. So I've saved a copy of the old project code, and we have character counter lib here. I'm going to grab my CS file from there and copy it into this folder. And I'm going to delete the class1 CS file. I noticed that when I was doing that, over in Solution Explorer, it now identifies that we have a character counter CS file here and not a class1 CS file. So this is different than the way Visual Studio works with sort of standard .NET projects. In a standard .NET project, we have to tell Visual Studio what files to include in the project. In a .NET Core project, we tell it what files to exclude from the project. So its default behavior is to include all the files in the project directory, which is why here we see that we have the character counter CS file already installed into the project. I didn't need to go in and right-click and do show hidden files and then add the file I wanted to see in there. It does that automatically for me. In my opinion, that's a much better way of doing things. It's much easier to include files in the project that way. So we have the lib. Let's go back in and bring the test project back over, just to show that we can run tests that we created from the command line against a project we created inside Visual Studio. So again, we'll do a new solution folder, call this thing test, go back out to the old application, and there was my test project. And there was my test project, and I'll copy that across to here. And then inside Visual Studio, add existing project, and we'll add in our test project. So the project JSON file, restores references, and if I go to Test Explorer and run the tests, so it identifies the tests, and sure enough, the test still runs. So before we add in our console application and show that running against the .NET Core library, I just want to show you one other thing, and that's the difference in the project JSON files between these two projects. The two projects being the one that we created on the command line earlier, and the one that's just been created by Visual Studio. This is the project file from the command line, and in here we can see we've got our version, some build options, no dependencies, and the framework details here, and the imports we need to use. And the framework details is .NET Core App 1.0, and it's Microsoft .NET Core App. If I look at the project JSON file that Visual Studio builds, it's much, much simpler. So in here we have our version, we have a dependency on what's called a .NET Standard.library, and then the framework is this .NET Standard 1.6, which imports this DNX core. So .NET Standard is the new naming convention essentially for the standard .NET libraries, what used to be called PCLs, now called .NET Standard. So there's information out on the web as to what it means by .NET Standard. This article here, for example, by Rich Lander. And the thing I wanted to show you here is if I scroll down, there's a table here which shows that the version of .NET Standard and which version of the .NET framework it corresponds to. So we are running on .NET Standard 1.6. So if I go back to Visual Studio, we can see .NET Standard Library 1.6, and that corresponds to .NET Core 1.0 and the next version of the .NET framework. And then .NET Standard 1.4 corresponds to .NET Framework 4.6.1, for example. So you'll start to see more and more NuGet packages, for example, using .NET Standard as for their dependencies. So we're more or less back to where we were previously, except that we don't have a console application currently. So what we can now do is go into here and do Add New Project. And what I'm going to add now is a standard Windows console application. And we'll call this again Character Console App. So to this I'm going to add a reference. But the reference I'm going to add, because we're mixing and matching project types here, so it has to be a DLL reference. So I'm going to browse the library and add the reference from the library. So if I browse to character counter lib, bin, debug, and it puts it into this .NET Standard 1.6 library. So it separates out the different versions of my DLLs into the different standards they support. So it puts the code into this .NET Standard 1.6 library, and there's character counter lib. So say OK, and we now have a reference in our app to the lib. So we've referenced the library inside the app. I've changed the app code so that we have exactly the same code as we had previously. So this is my program.cs file from the previous solution. So again, either takes a command line parameter, which is a file name, or it lets me enter some data on the command line. I've made the app the default project, so I can run the thing from inside here. So if I go to this and run the application fails. And it fails trying to load a version of system.runtime 4.1. So why is that? So if we go back to the lib and look in project.json, the framework this is using is .NET Standard 1.6. If I look at my application, then this is targeting .NET Framework 4.6.1. Previously, we saw that table that showed which versions of the .NET Standard worked against which versions of the .NET Framework. If I look at .NET Framework 4.6.1, that works with .NET Standard 1.4. So back in my project file, I need to say here that it's not using .NET Standard 1.6, it's using .NET Standard 1.4. So we need to make sure we change the Visual Studio project file to get this to work. It goes away and does a restore packages. So all the packages are now up to date. So once we've changed the version of the .NET Standard and we build the code, if we now run this again, it still fails. And of course, the reason it fails is that when we added the reference to the application of the library, this character counter lib, we added it when it was being built for .NET Standard 1.6. And we're now building against .NET Standard 1.4. So we need to remove that reference and add the correct library. So if I go to add reference and browse and go to the debug 1.4 folder and then add the library and now run, now the application works as expected. So now we're getting the correct output, and the application runs, and we're building a .NET 4.6.1 console with a .NET Standard 1.4 library. And life is good. So we've just seen the .NET Core is a cross-platform toolset from Microsoft, with the same toolset running across Windows, OS X, and various flavors of Linux. The tooling supports multi-project applications, so we can create more than one project within the application itself. We can also create test projects. So the tooling supports creating those projects for us as well as running the tests. We can load these projects into Visual Studio, either one of the standard editions from MSDN or into the Community Edition, as long as we have the right update in place. And we've seen that we can mix .NET Core projects with other .NET projects. So we mix a .NET 4.6.1 console application with a .NET Core application. So that was an introduction to .NET Core. Thank you. I hope you enjoyed the class.